So thank you for coming. My name is Pedrazas. I'm an engineer. I basically specialize on onboarding teams in Kubernetes. I live in London, and I'm one of the co-organizers of the Kubernetes London meetup. And during those meetups, we saw that people really struggle to get into Kubernetes. And then we decided to create something we call KubeCamp, which is training for the community. And it's basically 150 euros a day, and then you spend a day with me and some other people, and you basically learn how to interface with Kubernetes. And it's been going very well. We just announced 2 more trainings today in London and in Glasgow. So I'm going to talk about Soho House. Soho House is a private members club. This is Soho House Berlin. They have restaurants and hotels and spas, and I'm still not loading everything. We have 70,000 people worldwide, and this is the story of a journey of Soho House trying to get into Kubernetes. And as with all the journeys, started with a group of developers. Yeah, so we have a group of developers, and there's no ops, right? This is not the no ops that Kelsey Hightower says. This is the real no ops. We don't have on anyone who knows ops in the team. And fortunately, Juran made this comment the other day in Slack. I don't know why this has this weird echo. But, so it means that basically we are getting there. When developers feel confident, we're getting there. So I was one day at home, and my telephone rang, and then they said, we would like help to move all our applications to Kubernetes. Can you help us? And I said, yes. So, of course, they said, well, we want to move all the applications that are just, simple and low risk, and so just to get the hand of it. And I said, fine, yeah, that's good. So I went there, and then they said, well, actually, there's a problem, and we should start with the payment gateway, which is not exactly low risk. And loading, it's okay. It's basically, this image is basically fire, right? because this is what happens when you start with these things. But so I arrived there and said, well, we want a production cluster. And I said, okay, that's good. Production clusters are good. But people understand different things for production clusters. So I said, okay, what I like to do, and this is something that it helps you a lot to move and work with different classes. You have a way of creating a cluster, initializing the cluster, putting all the secrets, putting all the services that you will need, and then deploying the environment. If you have these 3 different separated blocks, you can manage and move from one cluster to the other. And when we went to production that day, Amazon had a problem with the DNS, not with S3. And I did redeploy everything in Google Cloud. It took like 15 minutes to build the cluster and just move everything across, right? So, and it was because we had this kind of approach. So to create a cluster, we use kops. We use kops because kops is awesome, and it's really good because it allows us to create clusters ready for production. And a cluster ready for production means that you can update it. You can upgrade the cluster. If the cluster cannot be upgraded, you have a problem. You will have to have another cluster, and then you have to be able to move your workload, which sometimes you can, sometimes you cannot. Right? So bear in mind, if you are getting into this world of Kubernetes and someone comes and says, well, that's the cluster, how do we upgrade it? I don't know. So, okay, we have a problem. Now, the other thing with kops is that it can run in a CI. Right? You can have all the descriptions in Git, and you can do a build, and you can know how the cluster has been created. You don't need any kind of magic. And the third thing that is really good is that it has instance groups. It means that you can create a cluster with different kind of groups of machines. So not all the machines have to be the same, because at some point you will have this case that I need to run this super heavy CPU job, or I really need to run Spark, and I need like all your memory twice, right? So instance groups allow you to do that and say, well, you know what, you run Spark in these ones, right? Monitoring, we use Prometheus, the other Prometheus. It's a classic joke that we do with Prometheus. Now, the thing with Prometheus is customizing and putting Prometheus in place takes a while. So we decided to move, well, to start using Cortex from Weaveworks. They're outside. And it's basically a SaaS Prometheus. It works fairly well. And they're going to put alerts. And once you have alerting there, that's it. You can, you can relax. Logging, we use Fluentd and CloudWatch. The same thing. If someone else can take care of my problems, and I just give them money, good, right? So that's what we do. One of the things that happens when you start doing things with Fluentd is that they say, well, my application is not writing the logs where they should write the logs. They have, these developers have put these logs in this weird directory. So we decided that, well, we will create this directory, and we have this convention, and then playing with volumes and volume mounts in the deployments, we can move these files into a place where Fluentd can read. If for any case you cannot do this because it's not working because whatever, you can still run a Sidekick container with Fluentd, okay? What is important when you start moving to Kubernetes is to understand that you have things like cluster and the namespace, and in this case, you don't have anymore your host, and you don't want to have your host anywhere, right? That's the way of knowing where is your application. My application runs in this cluster, in this namespace, and that's what we have. And then the joys of the CloudWatch UI, you have a way of getting all the logs of the application, right? So check, we are sorted with that. Circle CI. We use Circle CI for CI, and you can see that I have drone here, and this is because when you are moving into Kubernetes, you have the situation and say, well, what's the fastest way of me putting in the cluster? Because the experience and the learning that you will get from working the cluster does not come unless you are there. You have to get your hands dirty. And Circle CI was choking with we do beacon lift and shift, right? So they create this massive Docker container which was 1.4 gigabytes, and Circle CI could not build it. And we tried different approaches, and Circle CI couldn't build. Different errors, not nice. So I put drone, and we run drone, and drone build a image, we publish, we deploy it, and then little by little we start just breaking up the application, right? So always remember what is really important for you. CI is very important, but you know, the fact that you're using a system that's blocking you doesn't mean that you have to go through them. Can we go back to Circle CI? Yes, right? You have to choose. Well, you have this problem. I can put this solution. It can be a temporary solution that, of course, lasts forever, or I can have a more permanent solution. And the deployments, we use Helm. Helm, well, last year we were talking about Kubernetes and how we used to do things. I talked in the previous KubeCon when I was in the home office, and we had a little tool to do the deployments. We didn't have Helm. So we have Helm now. And one of the things that happens when you're doing deployments is that you don't have to put only one YAML file, one deployment YAML. You don't have to put just one thing. You have to put a set of files, right? And that's exactly the concept of release that Helm has. I will grab up all these files that you want to push and move them and tag them consistently. And if you want to roll back, Helm knows how to do this. I've modified these 3 or 5 YAML files, and these ones are the ones that I have to change, right? So that creates a very nice stream process in our Circle CI, right? And in our CI. In fact, our developers, what they do is git push, and the code is built. We create the Docker image, we push the Docker image, and then with Helm we deploy. And then we create an ingress rule that allows them to access that application, and the ingress rule is basically put in the Slack, so they just have to wait, the git push, go to Slack, my deployments, right-click, and then they access the application. And so we basically remove all the friction. And this is something very important with Kubernetes. Kubernetes provides deployments for free. You can deploy as much as you want, right? And that changed completely the way of creating applications. So this is our cluster, standard cluster, 3 sets, and then we have the normal machines and the big machines. So this is Kubernetes, all the components, vanilla Kubernetes. And then this is vanilla Kubernetes in an organization. And these red things are basically what defines your business. And ideally, what we want is to put these things into the cluster. And we don't want to have them outside, we want to have them inside. And if we can have APIs, it will be even better, right? Because what we want is basically to have one API only. Sometimes I give this talk about one API to rule them all, and it's basically this idea of you have Kubernetes as the interface, the unique interface that you have, and then you just keep adding your own APIs. And we do this using third-party resources and operators or controllers, right? It's these two patterns that you can use. Third-party resources, you can understand third-party resources as a data model, data that you can store in the cluster for whatever reason that you have to. And then the operator, everybody's talking about operators here. It's a name that CoreOS came up with. And it's basically following this pattern. I observe, analyze a problem, and then I react. And it's basically what operators used to do. I think that the idea is good, but you can get away with controllers, simple controllers that does only one thing, right? For example, the namespace operator, the only thing that namespace operator does is when you create a namespace, it will be triggered and it will be adding secrets that someone has decided that you have to connect to your Docker registry or to connect to whatever you have to do, right? So developers, they say, I need to deploy my application in this namespace, and it ends up there, right? So one of the things that happens when you start writing a lot of operators and controllers is that things get complex really quickly. The pattern is always the same. We watch the API. We try to see when an event happens. And if you look at all the operators we have now, the Prometheus operator or the HCD operator, they all have a certain kind of queue. And I'm not that smart. I know where my limits are, so I thought, I don't want to start writing queue systems for all these things, right? So I decided to put nuts. Nuts is built precisely for that. And it has its good and bad things, but it removes the problem of me having to deal with the queuing system. What happens with nuts, and it was something that I didn't realize, is that it lowers the barrier of entry. So suddenly, when a developer says, well, I have this job, and I would like to know when another job of like this one, or when these kind of pods start in the cluster while I'm running this job. And the way of solving this is very easy. You just go to the API server and watch for this resource and say, well, if you have one of these new things created, just notify me. But if you don't know how to do this, it creates a problem. But with nuts, I can say, well, you know what, you subscribe to this topic, and that's it. PubSub is something that the majority of developers understand very well. So suddenly, we could interface with Kubernetes by me just pushing all these events into a queue system. I'm sure that at some point, Kubernetes will have this as a native way, but in the meantime, well. The other thing that happens is we decouple the components. Now I don't have to have a controller that basically keeps going to the API and watching all the events. I can have one that watches a bunch and writes in all these queues, and then the consumers write are much smaller, and they just do one thing. Right? It's like if I get this event, then I have to do what I have to do, like creating a database, for example. Right? And it's the same kind of pattern that we have with microservices. So everything is good, right? So this is the example that we used to have. We used to have a Postgres operator, and what we will do is to have a third-party resource here where you describe, I want a database with this much size or this name and these settings, and then you send that to the API server, and the operator will watch, and once it receives the event, it talks with nuts, and then this guy here is subscribing. This is the consumer of the operator that uses Helm. It consumes a queue, and then using a chart, we go and create our database. And this basically what it does is to create a job in the cluster. Right? We create a job that runs a container that is running Terraform that creates my RDS. Right? And if you can see this pattern as well, by doing this, what I can do is basically separate all the concerns. I have one thing to build my RDS. I have another thing to manage the deployment. I have another thing that is in charge of the events. Distributed. So let's see what it worked for us and what it didn't. Remember that we are dealing always with these three things. We have tools and people. It's people all the way down, right? And each person uses tools in a different way. And you can have a process. And if the process does not understand or accept that people change and people work in different ways, so the process is flexible, agile, it will not work, right? Because buying tools, it's easy. I can go and buy a few tubes of paint and brushes, and then I can go and paint. But who can paint here? Who can draw? It takes a while. Everybody has the potential of drawing and drawing well, but you have to practice. Now, this is something that you have to understand. When you're getting into Kubernetes, you have to give you enough. You have to give your team enough time to practice. And if you don't plan for that, you will pay. You will pay a price. It's like, well, I didn't know how to handle this situation because it's too much. It's too many things at the same time, right? So you have to plan. One of the ways that we solved this problem at Soho House was me doing regular workshops. I will go one day and today we will talk about COPS. And a week later, today we will talk about deployments and how to use Helm or how to do backups. So it's basically spending time trying to learn and spending time with the people that they can go and learn. So adoption, it's basically a logarithm. Right? It will happen at some point that the whole organization adopts whatever that you have to adopt, in this case Kubernetes. Right? But it takes time, and how much time it takes, it depends. And so what we did is basically to get one application and use that application as the spearhead. It's like, well, we will try things with this application and we'll see how it goes. And if it works well, we'll adopt in the other projects, and if it doesn't, then we will just drop it. Right? Because change is hard. Changing the way that we do things, it is very hard. And here in Kubernetes, we're changing a lot of things. You change the way of building your applications. Right? You're changing how you configure your applications. You change how you deploy your applications. We're changing how we basically are writing software, because distributed systems are not like monoliths. And I'm not going to start here discussing about monoliths and distributed microservices, blah, 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 because that's not the point of this talk. But it is important to understand that you have to change, and you have to change a lot of things, and you have to plan for that. Right? And the more time that you have, the better that the elephant will come and hit you. Okay? So things that happens, developers really struggle with health checks. So knowing how my application is ready to receive traffic and how my application is not healthy and has to die, this is something that ops used to do, and now we have to do, right? And that takes a while. You have to give enough time to your people to understand how health checks work. Resources and limits are very important, right? Because things will fail. And it's one of the things that usually happens is my developers, or even me, I don't know how much CPU and how much RAM my thing is going to use, right? So one of the things that we do is to use with scope. With scope allows you to basically know how much CPU and how much RAM you're using at that point, Because that's the other thing. Is like, well, my developer say, well, yeah, but how do I see how much RAM I'm using? Because it's too complicated. It's in the cluster. I don't know, right? So there are different ways. And one of the nicest things of Scope is that it has a nice UI and allows you to do that, right? So limits are very important because what you have to do with limits, what we do with limits is contain the damage. If something happens in my application, I don't want to bring my cluster down. And if you are not careful, you will bring your cluster down, right? Another thing that happens is that people write all these tools and all these things, and they get attached to them, and you have to let them go at some point. So we had these scripts to deploy. Helm now allow us to deploy our applications much better. So you say, well, yeah, we spend a few hours and a few days or a few weeks writing this lovely template generator. It's time to go. Or the operator, the database operator that we had. At some point I said, well, you know what? It's not doing what I think that it has to do anymore. My developers have learned already, right? It's time to say goodbye to the Postgres operator. Why? Because composition is a much nicer way of dealing with these problems than black boxes. Right? So we have the application and a service, so this is a standard thing, but then this is the bit that the operator will do for you. But now, we have them in the Helm chart, and it's up to the developer to know when he has to create a database or migrate a database. And if you have the right health checks and the readiness probe and the liveness probe set properly, these things work fairly well, right? Because this is something that we know. Kubernetes is a really good orchestrator. Okay, what was not that great? You will find bugs. You will find bugs in Kubernetes, you will find bugs in COPS. It doesn't really matter which system or which tool you use, you will find bugs. That's okay, but you have to plan for them. What I was talking about the upgrade, if you don't have an easy way to upgrade, you have a problem, right? And I can give you a few examples of situations that happened to us. We were using the scheduled jobs, and one of the issues that we had was the API was returning the wrong kind of object. It was returning a cron object instead of a scheduled job. And cron objects were coming in 1.5, not in 1.4. So it was a bug that we had in the API side. I said, well, let's upgrade. Then we had another problem with COPS, and then we had to upgrade COPS, right? But the ability of, well, we can upgrade, it is very important. Another thing that people usually ask me is, well, can I use a small cluster? Yes, you can, but bear in mind that clusters are fragile. Small clusters can break, right? So just bear that in mind. It's totally fine, but sorry. It's totally fine, but and the other thing is, don't try to hack the process. It's like, oh, well, I will just, we used to do things like this. Now, because we have this new tool, let's try to do it like that. It's better if you just define a proper process that allows you to change, right? Otherwise, the process will break and things will happen. So I know a company that because they didn't understand English rules, they decided to put namespaces in everywhere. Because then with namespaces, I know how to call these things. And now they have hundreds of namespaces with one application running per namespace. And they were trying to solve the URL issue using namespaces, which is okay, right? No, it's not okay. But you get the point, okay? And last but not least, communication is very important. And this is something that happens all over the place, but with Kubernetes will happen even more. And it doesn't really matter which process you define, you have to be able to communicate changes, and with Kubernetes we have changes that are very fast, so it's quite difficult to keep track of what's happening, but it's very important that all your team understand as how the system is working and what to do and what to expect, right? And if you're going to upgrade, what are the implications of the upgrade from 1.4 to 1.5, from 1.5 to 1.6? Otherwise, you will have this situation of from 1.4 to 1.5, people still submitting scheduled jobs when they have to submit cron jobs. It's just a change in the API, but it was important. Thank you.